Okay, I need everybody to look up here. Who thinks they are an expert at Pythagorean Theorem now? You're an expert. Okay, I'm going to test you right now. We'll see about that. Yeah, there's some people that had their hands up, but they were not quite sure. That's supposed to be a square. Okay. Okay, what is the first step? Thank you. Y'all hear Hayden? We've got to label correctly. If you don't label correctly, you might as well just say, I'm missing it. You have to make sure you label correctly. Okay? So, they've already got A. Remember, draw your arrow. What side is that? C. So, this is going to be B. Okay, does everybody understand what I want? Where's the question mark? On the area of that square. Okay. So now the second thing is you have to do what? And you have to do what with it? Follow it. If you don't follow it correctly, you're not going to get it right either. So you got to label correctly, draw your picture correctly if there's a picture to be drawn, and follow the formula. Okay, so now, what's A? Why is it just 375? It's already the area. Guys, if you're an expert at this, then you know what C squared represents. C squared represents the area of that square, which you already know. Now, somebody said last period, in first period, well, just get the square root of 375 to find C. Is there a reason to do that? Because if you got the square root, then you just have to turn around and square it again. So they've already helped you out right here. They've already given you what C squared is. C squared gives you the area of that square. That's why we took all the time to cut those squares out for you so you could see. That's the area of that side. Now what do I do? 50 squared is 245. Plus? B squared equals 375. Okay, now look. If you had put 375 squared there, are you going to get it right? So you didn't follow the formula right. So you have to know what every part means. Okay? Now what do I do? Because you can't add that to B squared. Good job. So I'm going to go B squared equals. Good. What do you have to do at this point? Wait just a minute. What did I tell you to stop and do at this point? What do you stop and do right here? Check what? Check. Good, Caitlin. And to see what you're trying to find. What are you trying to find here? Are we trying to find B or B squared? B squared. We want the area of B. We want the area. So I'm done. I'm finished. I don't have to do anything else. Everybody get that? I don't need B this time. I want B squared. So you have to pay attention to what they're asking for. That's why if you're an expert at this formula, they're not going to trick you. They're not going to trick you because you're going to understand what every part means. A, B, and C give you the what? What do A, B, and C give you? The length. Guys, what does the A, the B, and the C represent? No. A, B, and C do not represent squares. The side length of a right triangle only. A, B, and C represent the lengths of the right triangle. What does A squared represent? The area of side A. What does B squared represent? Area of side B. Okay? Don't let them trick you, guys. Don't let them trick you. So here's another one that you might see. Okay, so we need to do what? Label. There's your right angle. That's side C. That's A. That's B. What are we trying to find out here? No. Question mark. Huh? The length of A, not area of anything. I want the length of A. That's why, guys, it's important. I noticed that some of you were writing capital A plus B plus C. Capital A squared. Capital, you used the lowercase letters. Lowercase. Okay? So we're going to write what? Tell me what to write. A squared. No, I tricked you. I tricked you. It's already the area, guys. Oh, you experts. I'm going to have to bring you down a few notches. I know. I heard who said it. Look, it's not 200 squared. That's not B. B is not 200. That's the area. They've already helped you out. What goes here? Not squared. Not squared. So now I can't add that, so I'm going to subtract 200. So A squared is 125. What do I do at this point? I've labeled correctly. I follow the formula correctly. Stop and check what? Yeah. Well, what do I want? What am I trying to find out? A or A squared? A. A. I'm trying to find A. So do I need to get the square root? Yes, I do. So A is about, not 12. 11.2 is what I got. Well, you got 11.18, and so you rounded to 11.2. We should know how to round to nearest tenth now. We've done that all year. Different situations have come up. Okay, anybody have a question about this? Okay, look at page 231. Okay, look at number 5. What did the directions say? Is it a right triangle? Who has a suggestion on what we could do here? Okay, Willie. Okay, fit them where in? Fit them in where? To what? Fit them in what? There you go. Into the Pythagorean Theorem. And you don't even have to draw this because really, can you draw a 60 centimeter, 61? It's not gonna matter, okay, if you draw it or not. What I can label the sides right there, can I? What's A? 11 has to be A because it's the smallest. And what has to be B? 60. And then what has to be C? Okay, now remember these could be switched, B and A. The legs can be. But C has to be 61. Did y'all hear what they said? Why C has to be 61? Why? Sean, tell everybody why. It's the largest number. It's the longest side. Okay, so all you have, and we're only doing 5 and 6, guys. So we're going to write down into here. So A squared plus B squared is C squared. What do I write on the second step? Good. 11 squared plus equals. Good. Who remembers doing this? When did we do this? When did we do this, ma'am? On the first day, didn't we? When we learned it on our grid? When I gave you the 3, 4, 5 and the 6, 8, 10. When we drew it, we proved that those measures work. Okay? So what's 11 squared? squared? 3,600. How many knew that without even doing the math, the calculator? Because 6 times 6 is 36. 2 zeros. What's 61 squared? Good job. Now what do? I add these two together. I'm not trying to find the length of a side. I'm trying to prove these work. So that's going to be 3, 7, 2, 1. Hey, look at there. Check. So what do you know? It's a right triangle. Yes, very easy. Hey, I want y'all to look at something because this might make a difference. So, somebody might need to hear this. Look. Let's say you know the 3, 4, 5 works, right? So let's say this is 3. What did I do? Okay, this is 4. Whoa. Okay, this is 3. This is 4. That's 5. Because somebody needed to hear this morning. Just a minute. Okay, so look. If this is 3 and that's 4 and that's 5, when you put these two, when you touch these, that's going to make a right triangle right there. That's going to make a right triangle. Okay? But if this is, where did I? Hang on. If this is longer than 5, okay, and let's just go from right there. See, I mean, it could be there. That could be the length of that side. I mean, it's going to make a right, it's going to make a triangle, but not a right triangle if this is bigger than 5. So you got to close it up to make, and so then that's going to be 5 inches right there. Does that make sense? Okay, some people needed to hear that this morning, so I just want to clear that up. Okay, look at number 6 now. So what's A going to be? Good. B? C? Okay, so we're going to come over here. A squared plus B squared equals C squared. Go, everybody go work it and see if it's true. If it's a yes or no. Did it work? No. 5 squared plus 12 squared is 15 squared. 25 plus 144 is 225. 169 equals 225. No. That means not equal, remember? So that's a no. So everybody sees how you go test 3 sides. Okay. Everybody look at 233. Skip to 233. Look at the bottom. Now, hey, do you know what they think 8th graders can do? A lot of work. A lot of different things. They expect you to learn Pythagorean Theorem and then use it all kinds of places without them telling you to use it. Okay? So what they might do is, I'm going to cover this up right here. They might give you 2 points and not even draw the line on a coordinate grid. They might give you 2 points, okay, on a coordinate grid and say, find the distance. And you know what I have people trying to do? Use a ruler to find the distance. It's not going to help. It's not going to help you to find it. They expect you to go, oh, well, look at there. If I draw that line and connect those 2 points, and then I draw me a right triangle on there, if I draw me a right triangle, then that's going to be side C, and I can use the Pythagorean theorem. They might give you 2 points on the coordinate grid, and they make a diagonal when you connect them. Now, if they gave you these 2 points, you just count the points, don't you? I mean, count from point to point. But if they give you 2 points and they make a diagonal, you have to think to yourself, oh, I can make me a right triangle and find side C. Okay, so let's go label. Let's put A there and B there. What's A going to be? Y'all see where she got 4? And what's B? Isn't it 5? Count. 1, 2, 3, 4, 5. You're just counting from point to point. And so then, hey, come up here in the margin where you have room. A squared plus B squared is C squared. So we've labeled correctly. Now we have to go follow the formula correctly. So 4 squared plus 5 squared equals C squared. Third line, everybody. 16 plus, guys, should I hear clickety-clack? I think we all know 4 squared and 5 squared. Okay, what's 16 plus 25? 41. Now let's stop. Am I finding the area of that side or the side? The side. So I've got to get the square root. So C is about good job. Now, guys, is 6.4 bigger than 5 and 4? Remember, your side C has to be the longest side. Okay, turn the page, 234, or look at 234. You might not be turning. Okay, I want y'all to look at something up there. This formula is a formula that you're going to learn in high school. You're going to learn that formula in high school. Okay? And it's going to give you the distance between the 2 points. Well, we just learned how to do that. We just learned how to do that. Okay? So this seems real hard. You subtract your x's, you subtract your y's, you add it together, get the square root. You've just done the Pythagorean theorem. Okay? So, turn the page, and I'm going to show you what they're talking about. 236. Several people, first and second period. Oh, I thought that was going to be hard. It's not hard. Look at the picture they gave us. They want to know how far it is from the house to Camp Sunshine. Well, they expect you to see, oh, that's a right triangle. So I'm trying to find side C of that right triangle, which is called what? What's side C? Hypotenuse. So, what do y'all want A to be? The vertical or the horizontal? We're on page 236. A, and that's B. What's the problem here? A while ago we could count. Can we count this? Oh, goodness. We can't count, can we? What are we going to have to do? They gave us the coordinates. We're going to have to subtract. Yay! Hey, let's do A first. What goes up and down? Y. So we're going to look at the Y coordinates of the points. So I'm going to look at 20 and 120. So what is that going to be? 100. God bless you. Does everybody see how they got 100? You're sure? It's important. You just subtracted the y's. Now, x goes across and b goes across. So now we're going to look at the x coordinates of these 2 points. So how far is it from there to there? 190. See, that's all that distance formula told us. To subtract our x's and our y's, and then we're going to use the Pythagorean theorem. You see? So we're going to go, we've labeled correctly, now let's follow it correctly. So what? Tell me what to write. 100 squared plus 190 squared equals C squared. Do the third line and then we'll say it together. Go. 10,000 plus, good, equals c squared. 10,000 plus that is going to give you what? 6,100. Stop. Freeze. Think. Am I getting c squared or c? I want the area of this side. I want c. I want c, don't I? So I'm going to have to get the square root. I think it's 0.7. Okay, so 214.7 meters. Okay, is everybody good? See how we got that? You sure? All right, look down at 3. We're not going to work this one. We're just going to set it up. So they want to know, guys, one plane leaves, it goes due north. Due north means straight north. You're not going northeast, northwest. You're going north. Okay, close your eyes. Point north, and freeze. Right. Now, freeze. Open your eyes and freeze. So if I want to go, okay, to Jasper is north. So if I want to go to Jasper, I'm going to go straight up. That is the funniest thing that y'all do. Guys, no. Good, Hayden. Okay, 96 runs parallel to us. So right now, 96 is out there parallel to where we are. So if you get on 96, you're going to go north to Jasper. If you get on 96, you're going to go south to Beaumont, Eunice, Silsby, wherever. Evendale. So north, south. North is not up. Oh, geez, Louise. Okay, so right here, guys, on this thing, let's look. Let's label correctly. Here's your right angle. They want to know the distance between the two planes. So what are we trying to find? The hypotenuse. Good job. So let's put A here and B here. Go figure what A would be. A goes horizontally. So A is what? 67. Because all you had to do was subtract your x's. Now B is going to be, yeah, because you're going to subtract your y's, 1 and 80. 80 minus 1 is 79. Okay? And then we know how to work it. Okay? Turn the page. Or look on 237. Okay. We're going to change up what they said to do. We're going to put E, which is negative 3, 4. Put E on your grid. Then we're going to put T, 4, negative 4. So, guys, if they gave you these 2 points on the grid, and they said, find the distance between them. This might be what they do. They give you 2 points. Well, first of all, you draw a line. You draw your line. Oh, this is T. They want the distance. They want the exact length of ET. Do you know what I hate people trying to do? Use a ruler. It's not going to do you any good. And then you know what they do, Jay? Some people go, well, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6. Can't do that either. You have to think, if I drew a right triangle, I tell you what, this time let's do it this way. So you have to think, If I made a right triangle over there, draw my arrow, that's going to be side C, and I can do Pythagorean Theorem. It's easy. And then on this one, all I got to do is count. So put A, put B. This time, oh, and make sure you're counting by ones, and you are, because that's 5, see, right there. 1, 2, 3, 4, 5. So A is what? 7, and B is, and then you follow the theorem, which we all can do. Easy, easy, easy. True? Okay. All right. You're going to okay. Are we good? Everybody knows what we're doing. The thing is, guys, on Pythagorean Theorem, like I said at the beginning, you've got to know what every part is. You've got to label correctly, follow the formula correctly, and find what you need. Don't find something you don't need. Okay? All right. Now, we have all that we've got to get done on the board in that order and turned in. D73, 74, worksheet 8.6. I'll write down. Close your book. Worksheet 8.6, worksheet 8.4, 8.5, and worksheet 8.2 some people haven't turned in yet. Those 4 things in that order. Okay, are we good? We know what we're going to work on? Okay, spread out or get a blinder. And you can listen to music and